Dear students, in the previous class, we have discussed the classification of technical progress given by Hicks. And we have used the per worker production function to clarify our points. There is an alternative way of representing technical progress and its classification. This is based on indifference curves. Let us see this also, because this procedure is used when you study technical progress in international economics, etc. Now, consider L here, K here. Now, if you draw a line from the origin, a straight line from the origin, K by L ratio will be same. Now, as a result of technical progress, as we have seen earlier, the isoquant shift towards the origin. It means the same Q can be produced with less amounts of capital and labor now. So from point A, isoquant shift to point B. Now let us define what is neutral technical progress. When we say that technical progress is neutral using the isoquants. Now, technical progress is said to be neutral if along a line in which K by L ratio is constant, K by L ratio is constant, the ratio K by L ratio is constant, MRTS is equal to MBL by MBK is also constant. This is neutral technical progress. When technical progress takes place, the isoquant shift towards the origin, equilibrium shifts from A to B, and if you draw a tangent at a point A, another tangent at a point B, and if the slope of the tangent is equal to the slope of the tangent at B, for the same K by L ratio, then technical progress is neutral. As you can see, K by L is constant along a straight line from origin. Whatever is the capital labor ratio, it may be 2, it may be 1, it may be 0.5, whatever it is immaterial. K by L ratio is constant. If it is 2, here also it is 2. If it is 1, here also 1. So, at a point A, the slope of the isoquant is MRTS. At a point B, the slope is again given by MRTS. So MRTS at A is same as MRTS at B. We have neutral technical progress. Now consider a second case. Labor, capital. Now we consider the second case, capital deepening. Capital deepening. Capital deepening means capital using or labor saving. So technical progress is said to be capital deepening if along a ray in which a K by L ratio is constant, MRTS declines. Again K by L is constant and MRTS is equal to MBL by MBK decreases. We know that technical progress is capital deepening if marginal product of capital increases faster than marginal product of labor, so that MRTS decreases. So, consider the original Q, and at point A, the slope is given by the slope of the tangent, MRTS. Now, as a result of technical progress, this Q becomes this new isoquant is this, and here the new isoquant at point B, as you can see, at point B isoquant is more flat, means MRTS MBL by MBK at B is lower than at A. So this technical progress is capital deepening. So capital deepening technical progress is one in which along a ray in which K by L is constant, MRTS MBL by MBK decreases, because capital deepening labor saving technical progress increases MBK relative to MBL. Now we consider labor deepening, or what is known as labor deepening or capital saving. Now consider this labor capital, the ray along which K by L is constant. Now this is Q at point A. So again technical progress is said to be capital labor deepening if along a ray in which K by L is constant, MRTS is equal to MBL by MBK increases. MBL by MBK increases. So at a point B, the same Q, but the slope of the isoquant at a point B is greater than at a point A, and at a point A and B K by L ratio is same. Because we know that labor deepening technical progress increases MBL relative to MBK, so that MBL by MBK increases. That is the slope of the isoquant for the same K by L ratio increases. So using the isoquants, we define technical progress as neutral, capital deepening and labor deepening like this. Neutral means MRTS remain the same. Capital deepening means MRTS decreases. Labor deepening means MRTS increases. This is the classification of technical progress by Hicks using isoquants rather than the per worker production function discussed in the previous class.